Just let me share. Is it visible?
Yes, sir.
Okay. Struggle, may I stop my video? Or is
Yes,
it
sir. Yes, sir. You may.
okay? So, fine. Okay, so it's okay now?
Yes, sir. Perfect.
Fine. So, good morning once again, everyone. And as I come to know that this is the 10th day in a row, so I believe a lot has been already covered, and you have been people have been there for since last 10 days. This is 10th day, probably the last day, and almost 18 session or more have been already covered. So quite possibility that part that I'm going to cover may have already it's kind of a revisiting. But still, I believe it's always in a there is a scope to get something new. So there is it's a worth to revisit the topics. There is no then I will jump to the cloud service discovery monitoring. So let's have a quick look. What we can do is since uh, so many sessions, insightful sessions have been already done. So I believe these basics have been covered. So we can quickly go through these. Let's see something new can be add on. So cloud computing, you see, is very popular nowadays and has been emerged as something new. Everybody's talking about this, right? So let's try to understand in a very simple words. Cloud computing focuses on the way in which we design computing system, develop applications, and leverage existing services for building software. So it's a new way of delivering services. In short, we can say uh, it makes us to rethink how we design our computing systems. It's make the developers also to develop their applications in a different way, so that can be made available over a cloud to everyone, and all other services, existing services for building a software can be provided over a cloud in a different way. So it's a new way of delivering the services in short. And again, we can say computing is being transformed to a model consisting of services that are commoditized and delivered in a manner similar to utilities such as water, electricity, gas, and telecom. This is, see, that seems very simple, but it's a very important to say any service as a cloud service. See, sometimes cloud services are also called as a utility service because services are provided as a utility just like our day-to-day in our day-to-day life like water, electricity, gas, etc. we use. And related to this, a very important concept or characteristics of cloud services is pay as you go. So to pay as you go, the services have to be rendered, provided in form of utility. Just like the way we use utility service and we pay for that. Similarly, cloud services also offered in such a way that we pay only for the part that we have used. That's make it different from normal conventional way of providing services. And of course, one another important concept that is dynamic provisioning. That means can be can be provided dynamically as and when required. It can be scale up, scale down, and configured at the client side easily, seamlessly. When I say seamlessly, it is a very important concept that Normally we use word transparent, that's something visible, but in terms of cloud services, we say transparent means in the sense that the user is required a minimum effort to get the service. All the services must be available once a user has been connected or registered with any service provider. You know, the major cloud service providers, the giants like Amazon, Google, Microsoft, these are big players. So, and many more are there, and every day there are new service providers are also providing their services. But once a user registered with any of the such service provider, after that there should be a minimum effort to be done. I mean, all the services that our user are getting from the service provider should be just like as if they are available to the local machine. This is very important. Otherwise, it's not going to be called as in a cloud service. They have to be available directly to the host machine as if they are available there. Just like you see one example, you say Dropbox, right? So it's just like you have a normal folder on your desktop and you are dragging and moving one file to that folder. Similarly, you are say moving one file to the Dropbox. Same effort is required, but there is a huge difference in both the cases. In one case, you have moved a file, it's still at your local system when you move a file to your data to your local folder. But when you move the drag and drop to the Dropbox, you know where it's going to be. It's totally it's there in the cloud. So this is a important difference that ki minimal effort is required from the user. It should be seamless. Similarly, user can access computing service based on the require. Of course, as and when required, it should be every user. Later on, we will emphasize on this point that ki every user have a different requirement. So services should be available as per requirement. User centric approach we will talk about. So now data cloud computing is, as I already mentioned, is a new way of providing services made available to the it's a state of art can be called as a data center. There are so many data centers are employed when you see the simplest example when you use Gmail itself or email, we get served every day by the Google. We never bother about that how many data centers, I mean through which data center it was routed, routing protocols or path. We never bother about that as an end user. We just log in and we get our email. One thing. Second thing, employing virtualization technology. Virtualization is again a very important concept to implement or to realize cloud services. Without the concept of virtualization, I think we cannot think of cloud computing. And let's see, let's take one simple example, though it's a very simple and raw example. You can say, see, virtualization specifically I'm talking about. And later that was extended to a broader sense. But one example can be like earlier, see, suppose we have a machine, we used to have machine our laboratories or desktop at home, and students have to make it dual boot or either have to two machine for Linux or Unix we have to install separately on another machine to work on it. Then after that, instead of having a separate machine, people switch to make it dual boot. Same machine having but after that now instead of making a dual boot, even on your Mac or Windows OS itself or laptop having a Windows, we simply install some VMs. Like one of them that I'm using Oracle Virtual Machine, Oracle VM. So I just when I start that Oracle VM, actually what happens that creates a virtual machine and install on guest OS or on the host OS. So Windows will be my host OS and all the underlying resources, memory, processor, all resources are also made available to the host OS, normally Ubuntu that I use. So when we start Oracle VM, that allows me to use Ubuntu. That means that virtually we have created guest OS, that is Ubuntu is working and making use of all the underlying resources seamlessly without any problem. as good as I am working on a Ubuntu machine. So that's what this virtual VMs created. Same concept has been extended to the distributed system. It's not like on a single machine. The example that I gave later, I mean, same concept has been extended to the distributed systems. Later on, I will come to point that how distributed system led to the or is a foundation for cloud computing. And as I already discussed, pay as per use. See, this is one of the important feature that we have to pay. That's how it differentiates from the conventional computing. How cloud computing is different from the normal traditional computing. That we have to pay only for what we have used. Let it be infrastructure, runtime, or environment, or services, any kind of services. So cloud computing services are provided as a, or convert turns into as a utility service. This is the important change or thing that Kiwi user is getting the services as a utility. Right? It has transformed the internet into a rich application and service delivery platform serving different complex needs, varying from a very simple service to any complex. Depending on the type of a user, depends ki what type of a user is. It may be a simple user, may not be a computer savvy. Still, making use of services knowingly or unknowingly. When I say knowingly or unknowingly, you see, uh, almost everyone is using a smartphone now. So cloud service is in use in day-to-day life now. Even a person who don't know anything about the computers or a cloud or anything is still having a smartphone. So knowingly or unknowingly, he or she is a user of a cloud service. Right, like backing up of a data, the mobile company offers us an option to back up the data to the cloud. Or not only even backup, even when using so many apps we are using on our mobile. So the user is indirectly using the uh, this cloud services. He or she may not knowing that, may not be a computer savvy, but still using. So this is how you see the cloud services are there in use in our day-to-day life. It has transformed. Now, I know there has been so many times that you have gone through the different definitions. So after having discussed about this or having a glance over the cloud computing, see, one thing is that there is no single definition. It depends how you understand and you can explain in your own way. Every author have his or her own way to explain cloud computing. But one definition that is by National Institute for Science and Technology says cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. For example, network servers, storage, application, and other services that can be rapidly provisioned and released with minimal management effort or service provider. You see here also with minimal management effort or service provider interaction. Every word have its importance. It summarized very well the definition of cloud computing. Ubiquitous, present everywhere here and there. As I already given an example that cloud services, the use of cloud services everywhere in our day-to-day life. Right? Convenient, yes. Very easily we are using. That's why I said keep knowingly or unknowingly. Sometimes even an end user don't know that he or she is using the cloud service. In fact, they are. On-demand network access to a shared pool of configurable computing. See, it's not limited. Normally, when we say cloud services, few people, sometimes it give storage. This is my personal opinion. I may want to normally the in broader sense we say storage. Even the example I gave was Dropbox or Google Drive. They both are example of storing the data. But we have to, to call it a cloud service in a real sense, have to understand that it's not limited to the storage. Though it may be like storage is still can be mostly or widely used by the user. Uh, especially those who are not from the computer or IT, they use to store the data only like a Google Drive and all that. But we have to broaden our view. It's not limited to storage only. It's about networks, about applications, it's about platform that you have already. I'm sure you have understood or studied those delivery models, deployment models, software as a service or platform as a service or infrastructure service. So it's not only to storage or infrastructure, but it provides even in a complete platform. A user can develop their applications, can use the platform of the service provider. So it makes the things very easily. And of course, depending on the requirement, it can be scale up or scale down easily depending on the user need. And I already emphasized the word that minimal management effort. It should not be like a user need not to do any extra thing. I repeat again and again that it should the user should get the services, either of the services, similar to only that much effort should be required as it is working on, as if the person is working on his own machine, right? Otherwise it's not going to be the real cloud sense feel of a cloud services. These are some common cloud services, as and when you have already, most of you have used. Even you see the platform we are using right now, this your WebEx. So WebEx is also an example, very good example, simple example of a cloud services. And if I ask you in which part of a delivery reference model you will consider, I believe everyone will be agree with me that it's going to be a software as a service SaaS. WebEx should be an example of software as a service. It provides us as a communication service to hold the meetings, etc. So this is one thing now. So a meaning is that you see, if you look at these examples, you see most of we are using or have used. Even if somebody is not from the IT or computer, still at least everybody is using the chat facilities or a email facility at least, right? May not be a I mean, the developer may not be using this Google App Engine, etc. But at least email or a chatting apps are the most common that even you can see every every taxi driver or every common person is using. Now let's have a quick review. You can say if you have already done that. Difference between your conventional or classical computing and cloud computing. So, in short, instead of going in detail, we can say when we are working without cloud computing, that means every station, every node have their own separate services. Let it be a software, hardware, storage, networking. Those there is no sharing. And no sharing of resources, and it's limited to the available resource to that local node only. But when you come to the with services, cloud computing services, there are going to be huge difference. There are going to be virtualized resources. That means virtually all the underlying resources of the host OS or the service provider are available to all the registered guest users by creating the by virtualizing all the resources made available to the end users. Automated service management services on demand can be, its elasticity and all that. Those are features, rapid scalability, location independent. Yes. Now it's not dependent where you are working. It's make the things very easy anywhere, in any geographical area. You get connected and can make a use of the services. A user can avail any kind of the services, can develop application from any remote location, not depend on the any local hardware need not to procure separately, right? Similarly, traditional model, yes, all nodes are separate, so have to make a huge investment and all that. There is something called I'm sure you have studied one term called upfront cost. So this cloud services makes this reduced or make this upfront cost almost nil. Upfront cost or upfront commitment is something that to prepare to procure all the hardware and software before you start work. Supposed to set up a lab at the institute to procuring and heavy machines, computers, set up and all the installing all the softwares, right? So you see one example I can share if you can relate. I remember earlier our students used to come to our lab, say for example C programming or C++. They used to rush to the lab technicians and ask for the compiler. I remember they come with a pen drive. Even if we go beyond that, there used to be floppies, floppy diskettes. So they rush to the technicians and they ask, okay, sir, kindly install or give me the compiler. I want to work practice at my home. So this is how it goes. Then it become very easier with the availability of the internet. They download themselves at their home. But major change nowadays, if you ask someone, they never look for any compiler. They don't want to install any compiler. They don't. They go directly online. And problem is that nowadays, sometimes even in a lab, when we give a problem, they directly don't. If mobiles are available, they directly online compilers are there. They directly write the codes, even the copy paste and the execute get the result directly and say this is the answer. So this is how things has been changed a lot. Things are available directly or services in form of cloud and other net services. This can be simple net example of net service. May not be the perfect for cloud. So anyway, the difference in cloud computing model when the remote is the shares services are shared remotely. Yeah, people working in a different location, different companies have an access. Google have their own data centers. Microsoft have their own. Amazon have their own services. I mean, sorry, data centers and servers through which we people are at different locations get connected and make a use of that. Uh, Further to go other differences within traditional IT and cloud computing delivery, their difference in terms of delivery model, bias, we already discussed that we have to purchase and how to invest. Upfront commitment and cost, I discussed that we have to purchase the machines and have to invest in hardware infrastructure and software. But in case of cloud computing, buy external services. That means buy external services, we pay only for the services. We don't pay for the extra hardware or you don't go for the supercomputer. I will go to that example also. So I want to talk about that single distributed. The difference in interface model here we use it works on a local network where we can go beyond local network to any level. I mean through internet with the coming of web 2.0. I think I have included one slide on that also through any web browser or through net, we get connected to throughout the world and get services from any part of the world. Business model pay for the this already we have done. Business models pay for the fixed assets. In case of cloud computing, we need not to pay for any fixed assets and all that. So technology model single tenant as already shown in the first previous slide that there is a only one user or a single tenant. That means can the services are only for whole and sole only for the single user of that machine who is using that particular system if we are using traditional IT. But in case of cloud computing, it can support multiple users, scalable, elastic, dynamic. Dynamically, it can serve multiple users with their needs while uh, increasing or fulfilling their demand, right? Like EC2, Elastic Compute Cloud of Amazon for Elastic example. And further, so conclusion, I mean, the difference can be concluded like this. In classical computing, from manually need to be provisioned, cloud computing, self-provision. In classical computing, dedicated hardware is required. In cloud computing, shared hardware are there. In classical computing, up to certain extent, it's a fixed capacity is there. Cannot go beyond that. Once you have purchased and once you have invested, I can go up to that part only. I mean, we have to upgrade, we have to pay more. Sometimes you have a machine, you have to pay for the further, you have to pay more for to upgrade your infrastructure. Whereas in cloud computing, it's elastic capacity in the sense that your service provider will look after for that. Classical computing, pay for the capacity, of course, what you have purchased, what you want to use, you pay for it. In cloud computing, I will pay for only for the subscribed services that I have subscribed for. In classical computing, there is a capital operational expenses, both. Whereas in cloud computing, I have to look for or worried about the operational expenses only. Not capital expenses are very limited. Limited in a sense that restricted to the minimum laptop or the machine that you want to connect to or want to work. Managed by the system administrator or the owner, whereas managed by the application provider. Which is the cloud computing. Now, one thing I would like to say, ki it's not like a one day. It's cloud computing is not something, or cloud services is not something that has been come out in isolation. Something very separate thing that have come uh, some from the isolation. Things evolve gradually, and cloud computing is also not an exception. It stands on the shoulders of other technologies or other things that we will take one by one. So let's a quick look. Somewhere in 1950s, mainframe computing was evolved. After some time in 70s, the concept of VMs was created. Salesforce came into 1999, started delivering application to users using a simple website. So you can say ki, the rough idea started, rudimentary. You can say, I mean, things started the concept of supplying, providing services from the single point. In 1919 itself, Salesforce already started thinking about that, started delivering the applications using simple website. In 2002, Amazon came into role, and today it's a very popular, one of the major cloud service provider. Amazon provided its first public cloud AWS web service, providing services like storage, computation. Then came Google, 2009. Google Apps also started to provide cloud computing services or application. And in the same year, Microsoft also launched Windows, Azure, and other companies like Oracle, HP have also joined the game. This proves that today cloud computing has become mainstream. So thereafter, because of these major big players came into the market, so cloud computing become mainstream. See, there are these Amazon, Google, and especially if I talk about the Amazon, there are services made available. Very vast number of type or diversified services are made available by these big players. And I mean, there are services for free also, although they are for limited time, especially for students. There are so many services are available for a limited time freely for the students, and students used to work on using those services very well in our lab. Now, we can say clouding is a new technological change, trend, new technological trend that supports better utilization of IT infrastructure, services, and application. Adopts a service delivery model based on pay-per-use approach, in which users do not own infrastructure platform application but use them for the time they need them. So just concluding the things, IT assets are owned and maintained by service providers who make them accessible through the internet, right? So we put the things that we have studied so far in a simple words about the cloud computing. Now, one more point, that is parallel and distributed system or computing serve as a foundation for building cloud computing system. So here I would like to give some time. As I already told ki cloud computing or cloud services are not something that has come up all of sudden and from something totally from different world. No, it's not like that. If you go in detail, you see parallel systems and distributed systems are considered as a foundation. So in other words, we can say we cannot think of cloud computing without the concept of distributed systems. There have to be have a concept of distributed systems. So how things उसकी see normal email or internet is the simplest example of distributed system, right? Parallel and distributed as if we go to the similarity in both the cases, more than one processing node is there. But when we say more than one node, but still using the same architecture, same machine on the same more than one CPU in a close communication on the same system, then we call it in a parallel system. But when these processors are on a different geographically scattered nodes and still we are utilizing them as in a single source, then that gives a feeling of distributed system. And as we know that same is required for cloud computing. The difference is that when we work on a parallel or when we have a processors in a close communication, they communicate via shared memory. And when we come to the distributed system, there the communication will take place through the message passing, send and receive primitives that we study in a distributed system. But anyway, we won't go to that detail of operating systems here. But the idea is that we have to understand, we have to accept this in our mind that uh, this cloud computing stands on the shoulders of parallel and distributed system. Primarily, we can say distributed system. Distributed system we can think in a more broader sense as compared to the parallel. So that's a real idea or technology or thing behind the implementation or building the cloud systems and application. Rajkumar Bhuya, this is the one presentation by Rajkumar Bhuya. I hope everybody, those who are in the field of cloud computing, they know very well this. Rajkumar Bhuya is a well-known prominent name in field of cloud, and he is a author of so many books. And he's there in Australia. He's a director of a lab, cloud lab. Anyway, they presented the things like this key, and this diagram shows that how technology or how things evolve with time or decades, at the difference of decades, starting from 50s to continued. Not only though this figure, this diagram goes up to 2010, but yes, things has been gone beyond that. Green computing, deep learning, etc., and all that CNN. But still, we can have an idea that you see how things evolve, this Flynn's taxonomy and all that you have studied, MIMD and MISD, SIMD and all this, this is they are they forms a basis for parallel computing and all that, and thereby for distributed and cloud computing. Right. This is how things evolve, right? And we see mainframes cluster grids forms the milestone. They form the milestone for the evolution or for cloud computing. And one thing I would like to mention how things changed. See, if you remember, I remember, if I'm not wrong, Param 10,000, long back machine, supercomputer by CDEC, our own Indian company. Param 10,000 was developed by CDEC company, a supercomputer. So earlier, the emphasis was or trials were to make a single machine more and more and more super or faster. But then there was a paradigm shift in computing, or there was a shift in the computing technology that key, because there is you see there is you studied different generations of computers and all that, transistors, VLSI and all that, how the size get reduced and price also get reduced, but still there is a limit. There was or there is a limit that how far you can extend the same machine or getting a same system to make the things process faster and faster. So instead of that, things moved from single machine to the multiple. getting the things executed from instead of a single system, dividing the work into multiple nodes. Then how these multiple nodes or processor are implemented, that's what the different issue, parallel or distributed, that gradually evolved. So we can say things shifted from single machine to multiple, and that lead to the idea of these clusters, grids, and all that. So let's have a quick review for these three major milestones. This mainframe cluster grids has been considered as a milestone for evolution of the cloud computing. Mainframes were large systems, of course, and to get more and more processing power, but there were some limitations for that. Mainframes cannot be considered exact example of distributed system. They offer large, of course, yes, they were devised to give a large computing power, of course, by using multiple processors. So there it started using multiple processor, more than one processor for our work, presented as a single entity. These are important thing. Multiple processors presented as a single computing power to the end user. And thereafter, different implementations came into existence that lead to the today's cloud computing. Then moving from mainframe to cluster, a cluster was an alternative technology advancement for to the use of mainframe and supercomputer. Cluster computing is a collection of tightly or loosely connected computing. It can be implemented both the way, tightly and loosely. I hope you have an idea that tightly have a close communication, that processor all have on the same system or the same architecture they use. They communicate via shared memory and they have their own local clock. Whereas loosely connected, normally we call the distributed system as in a loosely systems, loosely coupled systems, because uh, they don't have any shared memory. They communicate. Every system have their own local memory, and there is no shared memories. Whereas in tightly coupled system, there was a shared memory, and all processor communicate via shared memory, have a system clock also, and in case of loosely distributed, the communication takes place via message passing. Anyway, the connected computers execute operations all together, thus creating the idea of a single system. But still they are limited. The idea extended up to the local area network as well. The same concept extended to in terms of grid. So, in case of grid computing infrastructure that combines computer resources spread over a different geographical locations. So, it moved one step further, different geographical locations to achieve a common goal. And all unused resources on a multiple computers are pooled together and made available for a single task. And then cloud came into existence. The cloud computing is the delivery of computer definition we have already seen so many times. Cloud computing is the delivery. That's why I told you that there are different ways. Every time you see, every author have his or her own way to explain the thing. Once we have understood the idea, we can explain. So this including server, storage, database, networking, software analytics, intelligence over the internet, everything over the net as in a subscribed services to offer faster innovation, flexible resources, economic of the scale. Economic of the scale in a sense that we can use more and more resources are available with a minimum cost or a price. Some essential characteristics of cloud computing. Of course, already, once we have understood the definition, they already form a part of that, but still we can go on demand self service. Because I already said that a user need not to do any extra or exclusive offer to achieve it. Otherwise, it won't be a cloud systems. It would become a simple network service. In older days, the people working on a lab and they used to connect to network neighborhood and they copy the files from COD or E drive depending on the permission. That was a simple example of network systems, not neither distributed nor a cloud. There the files were moved manually. User do all effort, saving or moving from one system to or copying and all that. So that should not be that. Otherwise, to be call it in a cloud, it should be on-demand self-service as and when the service is required by the user. should be self configurable and can be easily scaled down or scale up as and when the user makes a requirement. A consumer can unilaterally provision computing capabilities automatically without requiring human interaction with each user service provider. I already explained. Heterogeneous access. Yes. One more thing. There should not be a restrictions like a person working on a Mac or a Linux or Unix cannot access the service provided by Amazon or a Google. It should be work for all all type of systems or operating system and even underlying hardware and architecture. Then only we can call it as a cloud services in a real sense. So it must support the heterogeneous. Excuse me. It must support the heterogeneous environment. Resource pooling, yes, only then we can make a resource best use of resources. Pool of service. See, even when we want to check our email, we go to the Gmail. We know Google or Microsoft or Amazon, they have pool of they have a pool of service resources in a sense ki they have so many data centers. They have at the different locations, and we never bother, and even we don't want to know, and we never bother about that ki from where or from which data center we are connected or from where our data is coming or going or saved and all that. And not only single user, it supports all possible users at the different countries or different locations. Multi-tenant model, that means key provider computing resources are pooled to serve multiple consumer using multi-tenant model, like multiple tenants in a same house, getting the water, etc., electricity, etc., made available to more than one tenant in the same owner. Same owner is providing services to multiple tenant. So same service provider making available all the services to the multiple users, fulfilling their requirement. Different physical and virtual resources dynamically assigned and reassigned according to the consumer demand. Well, there are some issues or some uh, point of research, or you can say points to work like migration, load balancing, cloud load balancing, or migrating cloud migration in cloud and all that. They itself they are a topic of research, but service providers have to think of those all those issues like load balancing and cloud migration, etc., so that they always keep on um, in a position. They always in a position want to be in position to serve the end user without any problem. So those all internal things keep on going on internally without knowing or without the knowledge of the end user. This is the important thing. Again, I'm repeating that it should be seamlessly and without the knowledge of end user. End users never bother about all these internal things that going on, right? Otherwise, we won't. This won't be the real say, definition of cloud systems. Measured service. Measured service. See, it's when we say it's pay as per use. We already studied that cloud services are pay as per use. So to make it pay as per use, services must be measurable or measured. How much service has been, which type of service, and how long it has been utilized by which user and user. Only then it can be made as a pay as per use, or a user will be able to pay for that. Subscribe. These are subscribed services, and we pay for the use. Pay as per use is the one of the important features. So I mean, it's a very simple idea that something which cannot see, something which cannot be measured cannot be controlled also. That's a different thing. Something I'm talking about. Something which cannot be measured cannot be controlled also. Similarly, in cloud services, they have to have some way to measure the uses, to measure the uses of the services by the end user. Although there are different pricing model, I'm not going to take those. There are different pricing models, that subscription based or tier and all that. But Depending on the pricing model, the end user will be charged, but still, in any irrespective of the pricing model, the and the pay as per use feature will be always there. They have to pay only for that. It depends ki how is subscription is done. That's a different depend on the pricing model, but still, it is there must be some way that the services rendered to the end users must be measured and accordingly uh, have to pay for that. It will provide analyzable and predictable computing platform only. Then let's have a quick idea of Web 2.0. Somewhere in the earlier figure, I have shown you that how the technology evolved, Ethernet and all that supercomputer, AJAX, Zero and all that from year to over year. So Web 2.0 also was an important development that transformed the use of the services. Or in fact, we can say it enabled the vast use of cloud services or made the use of cloud services easy. Web 2.0 or web is the first if we primarily we can say web is a primary interface through which cloud computing delivery its services deliver its services through some browser we have to access or through app. We need some device as well as some browser or app to connect to the service provider. Then encompasses a set of technology. Web 2.0 encompasses a set of technologies and services that facilitate interactive information sharing, collaboration, user-centered design, and application composition. Such evolved features have transformed the web. What happened because of these features that allowed the interactive information? See, if I'm correct, earlier it used to be very simple. One way, you can say kind of a one-way type of communication that we sometimes like a read-only type. With the available information, so we can read. But with the coming up of a 2.0, it's a totally dynamic, rich platform for application development, and it allows the flexibility, interactivity, and flexibility into web pages, which provide enhanced user experience that normally found in a desktop application. Can fill the form, can give the feedback, can interact, can give the responses and all that. And why we are because see, it is very important to make to make cloud services successful. These capabilities are obtained by integrating a collection of standards. Anyway, these are not limited to this. There are many. I mean, these technologies are evolving very fast. It's not limited to this XML or there are many who have come with the time. Utility oriented computing will also form a basis because we know cloud services are since they are delivered as an utility as a utility service, so there is a service utility as well as one software sorry service oriented that I have not included here. Utility computing is a vision of computing defining a service provisioning model for compute services in which resources such as storage, compute power, application and infrastructure are packaged and offered on a pay per use basis. So again you it's just like we are just taking a revisiting the definition of cloud as the first trace of this service provisioning model can be found in the mainframe. So as I earlier in one of our previous slide we talked about the different milestones that led to the evolution of cloud computing. There itself we saw it started with the mainframe era. In mainframe itself, the processing done from the more than one processor started. IBM and other mainframe providers offered mainframe power to IBM is considered one of the pioneers in the case of mainframe systems. Provider offered mainframe power to organizations such as banks and government agencies throughout their data centers. Uh, well, these are some reference models that you have already. I'm sure since you are yeah, this is 10th day in a row, and so many insightful sessions have been covered. So definitely, I'm sure these have been covered. So let's not go into detail. And user can be a user of a software as a service or platform or an infrastructure as a service. So these are can be some examples. EC2, Amazon EC2, Azure, Google App Engine is most common example of platform service, and also we can skip this part. Let's move to the next slide. Okay, now coming to something now see cloud-centric dynamic service discovery. With time, this cloud technology evolving very fast, and different users, not only these big players like Google or Amazon only, or this IBM or Microsoft. There are other players are also daily coming in the market, and they are coming up with their services. And there are so many cloud service providers are there available with their services. So and at the same time, one more point is there. When I use the word client centric, here I mean to say every user have a different requirement for different service. So with some assumptions, we are moving further. See, this is one example you can see here. So let's see, assume ki cloud application one is a tourism website deployed in the cloud, outsourced part of business to the other companies, provided and deployed in the cloud by other companies. So further, these air ticket services or hotel booking services, car rental services are further provided by different cloud services or different companies, but again in a cloud, in form of cloud. A single service or a service provider does not accomplish a consumer requirement altogether. Different services can be used in conjunction to create a new value added service composition to fulfill this requirement. See, the problem sometimes arises that there are service providers available. As far as service is concerned, that service is available, I mean, available in the market by several service providers. But problem is that how much we rely on that, how fruitful or exactly meets the requirement of individual service provider. So in that sense, we have to think about, see, there are number of functional equivalent services in the functionally equivalent means ki both the service, let's say there are X and Y service provider. Both X and Y service provider provides the service that you want. Here we are also assuming that we need a not only single, more than one type of service, a composition or a combination of multiple service we are seeking from the service provider. So though there are more than one X and Y, more than one service provider is available to provide your service. So we have to go for some non-functional requirements. See, the terms like utility or pay as per use, similarly, there are few more terms like QoS, quality of service. That means optimal service selection becomes an important. For that, we have see since both I mean multiple providers are available, service is available, but how far is going to fulfill your exact requirement? For that purpose, switching I mean instead of only thinking for functionally requirements, we have to go for non-functional requirements. That is some quality of service QoS, that is quality of service parameters like reliability or throughput or response time or these kind of parameters we have to think of. So have to analyze the services based on these non-functional parameters so that one composition or a composition of required service can be provided to the end user with most suiting or best possible matching the requirement of the end user. So that's why we gave a word client centric. So objective can be like QS based client centric discovery of cloud service composition, and another is if not meeting the requirement, suppose initially may meet the requirement, later on or may violate, So there may be a violation. So there are the two terms that you have studied. You might have gone through so far, like QoS, that is quality of service. For that we use non-functional parameters. They are this reliability, etc., throughput, etc. Whereas another term that how we decide it's up to mark or not, that is SLA, service level agreement. We can see this is a this is in a kind of a agreement between both the parties, the service provider and the one who's going to avail the services. Something agreed upon, that this is what you are going to get and this is what you are going to pay for that. So to keep these things in control, one idea is giving a priority or a weightage based model. Clients priorities for different, the basis is clients priorities for different QoS parameters, example response time, cost, throughput, reliability, etc. So for the same, we are assuming, or we are considering the fact, or building this idea on the assumption that every user have a different requirement for different type of service, have a different priorities, have let me repeat, have a requirement but with different priorities, right? So client may have priorities for different QoS parameters, example response time, cost, throughput, reliability, and hence need of composite services, sorry, or we altogether we can call it as a composition. Hence, there is a need of composite services satisfying the customer's individual QoS priorities, or based on the priorities of the client for individual or each quality of service parameter. We are considering or assuming here that for the same type of a service, a user may have a different priority for response time, cost, or through. Sometimes somebody is working for a security-based, government-based project or something, so cost may not be an issue, price may not be. So may given a very less weightage for that. Response time or reliability may be the most important. So we can model like something on a scale of 10, some weightage that we'll see next slide. Apart from that, different past experience with the service provider, just like you see, just an analogy, not an exact example. We are sometimes we search for something on Google, and we get links based on some ranking and all that. Google work on this ranking model and all. Every time we are getting first link based on the ranking. The first link appears to be the most matching to your search, but since we have already traversed to that particular link, and we found that is not the one that I'm looking for. So even as from the Google side, it may be the most matching for you, but still you don't want to go to that due to some past experience, or due to already you have explored and you find that this is not the something that I'm doing. Either you change for your search or you go down to the other link. Similarly, in a case of cloud services, there may be some experiences from the service provider, though they are claimed to be the best one, but the services that specific to that user is not satisfactory to that end user, and want to go to some other service provider. So based on that, also may want to change, or may want to change the weightage to the services. Further to understand one way that that makes a need for some tool, a requirement for some tool. We just name them. It's not some standard name. You won't find in some. You cannot. You don't say we have not seen. We have seen SAS pass, but we have not seen DMA. This is just a name given. Third party as independent cloud service discovery and monitoring framework. So just idea if there can be a tool implemented with the provider side or as a third party that gives a provision to the client to give weights, for different QS parameters. Like here we have considered price, reliability, throughput, response time, but there can be different. So gives a option to the client to give different weights to the different QS parameters, and then seek or look for or expect for a best possible composition. Now to find that composition, the problem can be formulated. The one idea, though it's not limited to there, after time, I mean, once this idea we perceived or conceived and then implemented, after that there have been other new technology or new ideas also came into existence, but still we can get an idea how things can go. User general framework says ki user makes a request. So suppose we have some engine or some model or some tool is there that gives us the best possible composition. To give the best composition, look for the utility. So need to compute the utility. That utility will be computed. Now here the utility will be the based on the QS parameters. Based on the QS parameters that provided by the end user, the system will try to find the most matching with the best maximum utility value services or composition of services. For that, have to make a use of some selection function, and we'll look at the cloud service available services, take the QS weight from the user, apply those user, and to avoid based on some, if there are some rejections or if there are some past experience, the services can be ignored or can go for further search. So for that taboo list can be maintained, that those all the previous results that has been rejected by the end user, according to, because reason is ki from the system side it may be the best. As I gave you an example of Google, from the Google side it may be the best matching link, is still not interested. So in here, as far as the theoretical or the mathematical calculated values, one composition of service may be considered as the best with the maximum utility value offered to the end user. But since the user already use or have some issues, so may reject it. By rejecting it goes to the list of rejected list, and then again run the algo to give the next possible composition. Here we tried with the genetic algorithm algo with the taboo search to get rid of the problem of local optima problem, to get out of I mean to get rid of the problem of local optimize. I mean, for local, as we use taboo as a local optimizer, you can say. So start with reading the QS parameters, and then get the service QS from the user. Call for the optimal service. For that, we call genetic algorithm implement. In fact, you can say hybrid of a blending of a genetic algorithm GA with the taboo. uh, so here we have not done any, I mean, GA with taboo here means taboo simply means ki we maintained a list of list of services that has been already explored and offered to the user, but user have not accepted that. We kept them recording those services so that they can be rejected or will not form a part of the next population. Importantly. So we'll apply that, and then we'll look for if the results are optimal or not. If they are good enough, and if want to accept as a offered service, then it's okay. Output will be given to the user, and user will accept. But before that, there is possibility, was this composition that is offering by the algo is already there in the taboo list. If it is already in the taboo list, then say we'll run the algorithm again and we'll look for some other composition. We'll keep on doing till that fresh or a new composition is offered. And not only this, even the offered composition of service or combination of services is new one. Despite of that, a user have a right to accept or not to accept that due to any reason. In that case, again, if it is not accepted, we'll add it to the list and we'll rerun the model or algo. This is how it continues for to find the best possible solution. To apply the geo, of course, we have to look for some fitness function based on some maximum. We try to apply the try to optimize this function based on the QS parameters for finding the utility of composition where minimum and maximum aggregated values of the ith on QS parameter of service composition C, we named it as a C, computed using this formula, or in fact we can say this is as an fitness function, or we computed a utility value based on that value we decided the system decides the service with having a higher the utility value will form the part of the offered composition. Here, I think, anyway, let me quickly go through. I want to and represent the service type, like service type 1, 2, 3, 4 can be processing, storage, etc. J1 to R represent the QoS parameters, price, response time, reliability, throughput, etc. Where Ji is the weight given by the user for any jth service of ith service. Jth QoS of ith service. Let's say storage. Ith service is storage service. Jth parameter may be like reliability or time, etc. Qij max is the maximum value of the jth parameter in all service candidates chromosome ith. We converted these compositions, different services by the different service provider as a chromosomes to candidate possible candidate services, and more than we have already assumed that we have federated cloud environment, more than one service provider, and having a service provider having a more than possible options, so to convert it as a combination of a more than one service with different QoS values for different QoS parameters. Similarly, we find minimum maximum value, and then for any kth candidate for ith service type, these aggregated QoS values across and services was calculated for price response time. Of course, optimization criteria minimize the reliability, throughput, response time. Reliability, throughput we would like to maximize, whereas price response we would like to minimize. In a form of sequence diagram, we presented user invoke the composition form, get the details, initialize the database or the algo, read the list, ask to enter the QoS parameters, enter the QoS parameter, user enter the quality of service weight is weight, enter the QoS parameter weight, ask for the weight, because we are building this on the assumption that every user have going to have a different request or priorities for the different QoS values. Then compute the composition, apply the algo, read the table list if already there, will according to looking at the table list will return the optimal composition as a result. Now if user rejects that, then go to the rejected list, add to the table list, and if it is accepted, then return as a success. This is one snapshot that service one, service two, random, some worked on some random dummy data, price, response time, reliability, throughput. These are some weightage given for different service for different QoS parameter by the client, and from there these are some solutions. Yes, there is a one problem that may arise, that after some point time gets stagnated, the performance may not improve, right? But still we find that key it gives the best possible, and there is some improvement. We tried GA with Taboo, so the basic GA with Taboo is so offering an option to reject and go for a next services. So up to certain point it improves the solution, like we see here. So here it indicates what? It indicates key after the service tool indicate key service 1, 2, 3. Service 1, 2, 3 can be any cloud service composition or a combination of service, and according to the tool, they recommend that service index is 657. So for example, this says key out uh, according or as per the given QoS parameters or the weightage. I repeat, on the basis of the given quality of service parameter weightage, by the user, end user. These are the services that best suits, or is this is a best possible one of the, since we are applying an evolutionary approach here, one of the best possible service compositions is 657 means out of the available service one, let's say is storage. So they are assuming that there were n number of storage service provider, 10 service providers were there. So this tool says ki sixth one is better with these values of QH, price or response time, throughput, reliability. These are some random data, I mean dummy data worked on the dummy. Service to fifth, so it can be like a processing. Suppose the user was looking for some processing facility, so this says ki the tool says ki fifth processing service provider was better with these price, response time, throughput, reliability values. And seventh service 3 is considered as a better for the given QoS parameter for the user with these QoS parameter values, and shown a shown an improvement in the utility value. So the model was developed using hybrid algorithm based on genetic algorithm and taboo search methods. The model discovers the most suitable service composition, incorporating the weights to the QoS parameter corresponding to each of the services given by the user. The experimental results show that the model performs better in terms of determining user-centric QoS-based service composition. Now, going to the violation, the tool that I used is not included here, but let me give a brief idea. We already worked with, we extended the same concept of utility. Based on the utility, there must be some violations. To predict the violation, have to check against the SLA database, service level agreement, assuming that we have that agreement details. So if the services provided by the service provider going beyond or out of those agreement limits, so we consider those as an violations. And further, to meet or to overcome those violations, still services need to be continued, so there have to be some adaptation is required. For those adaptation, again, adaptation is the change in the composition. For that, we assume that there are going to be some cost for that. So violation occurred, need to be serviced or need to make a further changes in composition. So need some adaptations need to be applied. For those adaptations, we have assigned some cost for that also. Based on those costs, again re-evaluated the utility value according to that utility. So the main idea is that again the basis is utility value only. So QoS service composition, a composition. So here, if I give you brief, a composition selected as a candidate solution by the algorithm. Composition monitor monitors the selected service composition for the violation occurred. Violation predictor that predicts the level of violation against the service level objectives, that is SLO, and also determines the violation cost. SLA database, service level agreement containing the details of the quality that customer demands. Composition adaptations determines the required adaptation for the selected QoS composition. Adaptation actions determines the possible adaptations to meet the SLA with minimum adaptation cost. And adaptation cost is cost incurred due to the incorporation of adaptations to meet the SLA requirement. Further adaptation against SLA violations, we modified, memetic algorithm, and we compared two algorithms can be used. Again, I repeat, is not limited. It's not, we cannot, we don't claim that these are the best. There can be other algorithm which can result, but we compared with two, memetic and Pareto optimization. In memetic, again we applied GA with local optimization. So if we see the differences, the conventional or the normal basic GSAs, we start with some population, make a selection, we do the crossover, we do the mutations, we keep on doing this while some break condition is not fulfilled. Same thing apply, but some local search strategy will be utilized. Generate the start population, selection crossover will be same steps. Only thing is that one local optimization will be done uh, till, and this will continue till the while condition is not fulfilled. But this local optimization again will be for some optimize criteria must be there. So uh, based on that criteria, we try to get rid of the local optima problem, or keep on changing. In short, we'll keep on changing the population or sample space selected. So as I said, we use the same fitness value utilization utility value, but only thing we added here is utility will get, see, when there will be a violations, they need to be dealt with. See, those to deal with the violations, have to rerun, have to apply some adaptations, and that also have some equivalent cost or price. So that will affect in reduction of the utility value, decrease the utility value of that particular composition, because the additional cost have been incurred due to those violations, and thereby adaptations applied. So due to that reason, there will be an effect on the utility value. So in general, the basis is still the utility value. Based on that utility value, the composition is still decided on that basis. So we use some this is cost of adaptation from service I to service J as a system parameter, combination constant. One more thing is that not only violation, there are some constraints in the composition also. Sometimes we say this particular service cannot go with this particular service or some other service. There are some constraints in the combination of the particular services during the registration of the services that also have to be uh, taken care. And then some normalized violation cost based on some threshold values. Some have to normalize, should not go beyond those values. So that gives you the violation cost. So after summing up all these as in a total cost, need to be deducted from the utility value to get the actual utility value to decide the service composition to be offered to the end user. Memetic has already shown through the diagram, generate the population, that chromosome set of service composition, compute the utility value of each chromosome, generate reproduction pool, compute the violation matrix, perform local optimization search over the current population. To do so, we need a taboo out the inferior chromosomes. Taboo out the inferior chromosomes. Here I already explained that we have converted those service composition for each QoS parameter as a one composition or or chromosome from the reproduction pool, and replace with the locally muted chromosome. If better, we will repeat this step 3.2 till the reproduction pool is full as decided. Perform the crossover. We use normal single point crossover. Perform mutation with given mutation probability. Repeat from the step 2 until given number of iterations are over. So we concluded as an although violation cost we found, though I have not included a snapshot, we realize that violation cost grows similar to in memetic algorithm as compared to normal GA. But still we found that after applying the adaptation cost in a memetic algorithm is lower on an average. What I want to say is, when we compare basic GA with blended or GA with local optimizer that we call as an memetic one, gives better performance in terms of, though violation cost does not get reduced in MA also, but on applying the adaptation cost we got a better performs better as compared to the normal G. Hence, the utility value of the adapted output composition is apparently better in case of memetic algorithm as compared to the basic GA. We also tried with the Pareto optimal genetic. Pareto here simply earlier we in a no, in a first attempt we compared the complete composition with another composition like service 1, 2, 3 is three services, and we say the service 6, 5, 9 is one composition provided by the tool. So all together we compared with the another service. But here in Pareto, we try to compare one to one, like price of one service with the price of another service, with the reliability or value of one service to the reliability of other service, and we try to compare and then perform the same GA only with this difference of comparison of one to one. But still, we found that key MA memetic algorithm does better as compared to Pareto ordering. It was concluded that memetic algorithm model better suits for task of dynamic cloud service composition adaptation in the face of SLA violation. So that was a one idea that was conceived and tried to implement. There can be with the time, as we know in this, especially in cloud computing or in IT, there used to be every day we find very soon we get new concepts and new algorithm and new technology come up that can be applied for the better performance. So yes, I do agree there can be better approaches, but this was one of the idea that we conceived that how the different services with the different values of different QS parameters can be conceived as an one composition and compared with the GA chromosomes and then finding the utility value and trying to make a one composite composition of services offered to the end user. This supposed to cover a bit. These are some initiatives, though many more has come after that was afterwards also. But since I have included, so we can CCICI Cloud Computing Innovation Council of India. CCICI is, I know many of you already may be member of this. Is an open platform aimed at bringing together subject matter experts across government, industry, and academia to collaborate and innovate with the objective of accelerating the emergence of the Indian IT ecosystem as a strong global leader in the cloud computing technologies for emerging market. It's an open forum with subject matter experts. Many experts are part of these groups and they keep on contributing this, participating as a volunteer in working groups, delivering innovation proposal and outcomes such as standard recommendations, interoperability test beds, certifications, benchmarks, also offer for white papers and reference architectures, pilot projects to develop prototypes, demonstrations, proof of concepts, etc. Research projects resulting in eminent publications and intellectual properties. They work for policy and regulatory recommendation also. Incubation of innovation promoting entities, innovation sandbox, innovation cluster, etc. Since this term sandbox, I hope you might have come across this term sandbox. Here it's in a different sense, but when we talk in cloud virtualization is a separate, very important concept in cloud computing. We cannot think of implementation of cloud computing without concept of virtualization. So I remember, I mean, one concept is sandboxing. Sandboxing is executing in isolation, providing a separate environment to execute something so that it does not affect the entire execution. Any changes made will be restricted to that part only and will not affect the entire execution. So this is a one way to separately executing something and seeing the results and effects so that it does not affect the complete system. Anyway, further, this CCICI also have capability building through conferences, workshops, e-learning platforms, design challenge awards, participation in global forums, etc. Further, there is something Megras. I already said that there have been many more have been added. It's not limited to this. Many other initiative, very fast government is working. Many other initiatives already have been taken. But anyway, Megras, the Department of Electronics and IT (DIT) in India has launched Megras GI Cloud, right? A national cloud initiative to help the government leverage cloud computing for effective delivery of e-services. GI Cloud Services Directory will be created to help public sector organizations find and subscribe to relevant services. NIC National Informatics Center also have their contributions in terms of cloud. NIC's cloud computing approach provides government partners with an opportunity to cost-effective manage technology resources, which accelerates speed to market and delivers resources on a scalable as needed basis. NIC private cloud offers federal, state, and local government partners the state-of-the-art, high-performing, and fully secure hosting operation that supports secure transaction processing worth several billion dollars per year. In fact, it's many more. Indian Banking Community Cloud (IBCC). IBCC is the first community cloud initiative for banking industry in the world. The theme has been to optimize cost while maintaining desired levels of efficiencies and security. The initiative plans to provide platform as a service, software as a service in the year 2014. IDRBT has also developed a cloud security framework with relevance to banking industry. So this was a brief, though it's a presentation. You can say I tried to touch some basics and some model to look for a particular user-centric services. So here I finish this. Thank you.
Participants, if you are having any queries, you can put up in chat.
Follow. Oh, wait for me. I'm in presentation. Ah, yes, I will. Wait. I'm coming there in next minute. Wait. No, be there only. I'm coming to my. Okay. Welcome. So, is it okay?
Yes, sir. So I think there are no more queries.
Okay.
Thank you once again,
Thank you.
sir, for contributing to our FDP and giving such insightful informations.
Oh, thank you for giving me opportunity. Thank you very much. Thank you. Say thanks to my Mustaq sir also and Jitendra sir. Thank you if you are there. May I leave?
Yes, sir. Yes, sir.
Thank you.
Uh,
Okay. Thank you. Thanks very much.
So to the participants, the next session will be starting at 4. So please kindly join.